Hello everyone. Today I'm going to present an update on the AgResults Foot and Mouth Disease Vaccine Challenge project. AgResults is a $152 million multi-donor initiative that uses a pay-for-results prize competition to incentivize the private sector to invest in high-impact agricultural projects that help to achieve the following goals: to reduce food insecurity, to improve household nutrition and health, and to increase livestock productivity. The sponsors of this programme are the Australian, Canadian, British and US governments, the Bill and Melinda Gates Foundation and the World Bank. There is a considerable challenge in controlling foot and mouth disease in Eastern Africa. Firstly, currently no suitable vaccine addresses all Eastern African regional risks. FMD is a complex disease with high variation in strains, which increases the difficulty of developing an appropriate vaccine for the region. Vaccines currently available in Eastern Africa are not effective against all local strains. Secondly, even with a suitable vaccine developed, the private sector is unlikely to distribute vaccine in the region, given current market conditions. In most countries in the region, governments control FMD vaccine purchases and consider the vaccine to be a public good. No multivalent FMD vaccine has been formally registered in the region because they are procured through specialised processes or tenders. These government purchases are often reactive to outbreaks, leading to unreliable market demand. And government purchases and distributions do not sufficiently meet the addressable market due to constrained budgets and political priorities. The AgResults Foot and Mouth Disease Vaccine Challenge project is an 8-year, almost $18 million prize competition that supports the development and uptake of high-quality FMD vaccines tailored to meet the needs of Eastern Africa in 6 target countries. These countries are Burundi, Ethiopia, Kenya, Rwanda, Tanzania, and Uganda. The project has 3 objectives. Firstly, development and registration of high-quality FMD vaccines tailored for the needs of Eastern Africa. Secondly, increased vaccine production and regional purchases to create greater market stability and to reduce price of vaccines. Thirdly, development of a private sector model for buying and distributing FMD vaccines to complement the public sector efforts. To achieve these objectives, a cost share mechanism has been designed to include public and private sector buyers. The project has an approximate 8-year timeline over 2 phases. Firstly, the development phase, where manufacturers will be developing vaccines suitable for entry into the competition. And secondly, the cost share phase, where those vaccines will be assessed as suitable for the competition by the judging panel and will be then entered into the cost share phase. We are currently in year 2 in the development stage. For a vaccine to be eligible for entry into the cost share phase, the vaccine must first meet the following conditions in phase 1. Firstly, the vaccine must be developed to target product profile specifications. It must be a quadrivalent vaccine of at least 6 PD50, containing serotypes A, O, SAT1 and SAT2 that are shown to match circulating Eastern African foot and mouth disease viruses. The vaccine must have a 12-month shelf life, a 6-month duration of immunity, must be DIVA compatible, and must have a vial size appropriate for use by smallholder farmers in the region. Secondly, the vaccine must be registered in at least 2 of the target countries. These target countries are, as I've said before, Burundi, Ethiopia, Kenya, Rwanda, Tanzania, and Uganda. We are hopeful that the first vaccine will be submitted for registration by the first quarter of 2022. Following submission, the vaccine must be approved by the AgResults judging panel. We have a judging panel composed of FMD industry and regulatory experts, and they will review FMD vaccine applications and grant appropriate approval for vaccines that meet the eligibility criteria above. This map highlights the location of the globally located regional virus pools and serves to highlight Pool 4, East Africa, in which our project is based. This slide provides a focus on the FMDV status for each country in the region. It can be seen that type O is very common along with type A, but also SAT1 and SAT2 are prevalent in many of the countries. The competition countries are highlighted in this greyish-green colour. This slide highlights the complexity of FMDV serotypes and strains which are circulating in the East African region. As I've said before, there are 5 serotypes, OA, and SATs 1, 2, and 3 in circulation. But within these, there are at least 15 different strains or topotypes associated with these countries. For instance, in Ethiopia, at least 10 different strains have been identified. In Kenya, 5, Tanzania 3, and Uganda 7. Plus, of course, the outlying countries, which are the neighbouring or bordering countries, also have their own strains circulating, thus adding to the complexity of the control situation we are facing. This slide highlights the approach taken by each country in the region to FMD vaccination. It can be seen that some countries undertake a targeted approach, either targeting a specific species or type of animal, mainly dairy cattle, or a specific region, such as a border region, where there is more chance of transmission of disease across borders. The boxes demonstrate the serotypes of vaccines which are used in multivalent vaccines in the region. To ensure that vaccines entered into the competition are suitable for use in the region, they will be tested against the Eastern African FMDV Reference Antigen Panel, which has been put together by the World Reference Laboratory at Pirbright. This panel contains 16 strains clustered into 4 serotype sets that are representative of the viruses currently circulating in Eastern Africa. There are 4 serotype O's, 4 serotype A's, 4 serotype SAT1s, and 4 serotype SAT2s. For each vaccine submitted to the competition, cattle sera generated by vaccination will be tested for relevance to the region by virus neutralization test against this panel. There is a minimum pass rate, and for more further details, these are all available on the Pirbright website. The AgResults FMD Vaccine Challenge project was officially launched on the 22nd of January 2020 in Rome, Italy. At that meeting, 10 vaccine manufacturers attended, which was very positive, and since then we have added more than 200 contacts to our database that receive regular updates. There are 33 FMD vaccine manufacturers and more than 160 additional contacts, including NGOs, the reference laboratories, research organisations, universities, regulators, and government representatives. Among the many achievements of the project so far has been the development and adoption of the TPP as a standard for FMD vaccine quality and efficacy, engagement with global FMD vaccine manufacturers to ensure that there is interest in the project, engagement with national FMD vaccine regulatory authorities, collaboration with WRL on the OIE twinning project to develop the capacity of AU PanVac, adoption of WRL's Eastern African FMDV Reference Antigen Panel as a standard to test vaccines for relevance to the region's circulating FMDV strains, collaboration with Veterinary Medicines Directorate UK for harmonising evaluation of FMD vaccine dossiers, development of public-private partnership framework to address challenges in the vaccine value chain, an introduction of the cost share mechanism to provide financial incentive for public and private sector buyers. We have also engaged with regional stakeholders frequently in both the public sector and the private sector to discuss the project. We've spoken with CVOs, veterinary authorities, vaccine manufacturers, and even the national ranches and livestock enterprises in the region. We've also spoken in the private sector with the vaccine distributors and suppliers, dairy enterprises and cooperatives, and livestock exporters, to name a few. We've also had several discussions with the OIE, FAO, EUFMD, AU PANVAC, and assorted regional associations. Along with continued updates to contact lists and on the GalvMed website, there have also been a number of recent publications regarding the project. The first is an article that has appeared in a recent edition of the Viruses Journal, Global Foot and Mouth Disease Control, and the second are GalvMed blogs, which have appeared on the GalvMed website, explaining the public-private partnership framework and the sustainability of supply and delivery of foot and mouth disease vaccines. We have a number of ongoing project commitments and engagements, and that'll be with manufacturers to increase awareness, provide support, and address the questions regarding entry into the competition. We anticipate that several vaccines will be submitted for registration in 2022. And we also have a number of engagements with public and private sector stakeholders in the region to catalyse involvement in the FMD vaccine value chain, including distribution and vaccine delivery networks. So to summarise, the AgResults FMD Vaccine Challenge project aims to ease the negative impacts of FMD in Eastern Africa by supporting the development and uptake of high-quality FMD vaccines tailored to meet the needs of the region. The AgResults solution will combine both high-quality vaccines with improved distribution and delivery networks. Thank you very much for your attention.
So thank you very much for all of our speakers. Very excellent presentations. Now we'll go for the question session, and I will request Dr. Francisco to take the questions for our invited speaker first. Then we'll go one by one between Francisco and myself. Thank you.
Oh, hello, everyone again. We're going to start the discussion of this session, that is the last session of this GIFRA 21 meeting. We have listened to a set of interesting talks dealing with different topics related with vaccination, FMDV vaccination, from new vaccines such as peptide vaccines, presented by Catalina Avendaño, also vaccine strain matching, presented by Cecilia Caldevila, control strategies and regulation issues, presented by David McKay. Unfortunately, David has not been able to join us this afternoon, and Fabrizio Rosso will answer any question related to this presentation. Another interesting presentation dealt with natural stable vaccine candidate by Julian Seago, and finally a presentation regarding the development of regionally tailored vaccines presented by Jeff Hammond. Well, having made this brief summary, we can start with the question that have appeared on the chat for the moment. And the first one goes to Cecilia. And the question is, the current practice, sorry, not for Cecilia, because Cecilia is yours, Satya, is for Catalina, sorry. Cecilia was the first one. The question is, when we all know that for protection against FMDV can be afforded mainly by intact capsid, how the peptide vaccines will be protected, and if so, whether it will be equivalent to capsid vaccines, both inactivated and VLPs.
Okay, thanks for your question, Dr. Satya. Well, normally immune response is generated against pathogens polymorphic regions. It is due to these regions are most attractive for the immune system. So conserved regions used to be very important for the invasion or adhesion to the host cell. And as evasion mechanisms of the pathogens, these regions are used to be very poorly immunogenic. So in these type of vaccines, the peptides have been selected from conserved regions, and peptides have been modified to get a better match to the pockets of the major histocompatibility complex class 2. In this way, we improve the immune response. With these modified peptides, we found titers of neutralizing antibodies over the cutoff indicated by the OIE. This is not the only vaccine with the only peptide vaccines. These begin with with malaria. I work with Dr. Patarroyo, and he have been work with this kind of vaccine around 30 years. So the important here is the modification of peptides. Peptides without modification used to show have a poorly immune response.
Okay, thank you. I also have a question for you. And was the sequence conservation the only criteria you consider for selecting initially your peptides, pp1 to pp3 peptides?
Was the conserved sequences were obtained from the protein data bank from O serotype, A serotype, Asia serotype, and one SAT serotype. It was the SAT1.
Yeah, but you did not consider any other criteria, as for example, the possibility of being recognized by MHC class 2 molecules or something like that?
Yeah, when we select the conserved regions, we synthesize the peptides, and we carry out binding assays using the BHK21 seals, and determine if these peptides are important in the binding of the host cell.
Okay.
And later, using the NETSPAN2, we choose the match with the major complex, major histocompatibility complex. But this match is have a variability. It depends of the alleles of the cattle.
Okay.
Thank you. So we can go now to question to Cecilia. I think this question is from Go to Cecilia. The current practice for vaccine matching is to generate reference serum by vaccinating cattle with a monovalent vaccine. What is the rationale behind O1 Campus, A24 Crozerio, and the A2001 Argentina vaccine used to generate the reference sera for matching? I will go by one question, Cecilia. So when you finish this, I will go for the second question.
Okay. Thanks very much for the question. Yes, as you mentioned, yes, it's right that the current recommendation for the assessment of the R1 value is use the bovine post-vaccinal serum with monovalent vaccine collected after single vaccination. And the answer for your question is that we use serum, both vaccine and serum conferred by the vaccine that is currently used in the field, because we have to consider that the potency of the vaccine it's influenced for many factors, and we have to. It is important to consider the high quality and the high potency on the vaccine and the vaccine as a whole, the vaccine that is used in the field. So this is the reason that we used the polyvalent swine sera.
Okay, thank you. So another question from Teresa to you, Cecilia. So in your experiment, you use high potency vaccines, a dose of 6 PD50. Is this titer calculation from a preliminary study in pig with homologous challenge, or you use the titers obtained with the same batch of vaccine in cattle?
Thanks for the question. Yes, we have preliminary study performing in swine. For the homologous vaccine strains.
Okay, so I will have a question to carry forward from this question. So you are using this 6 PD50 vaccine as emergency vaccine, and this may be useful in some of the sea countries or in Far East country like a free country like Japan, Korea, but South Korea. But how you are planning when these viruses are circulating in endemic country in Southeast Asia, where the vaccine use only 3 PD50 vaccines in endemic countries, not 6 PD50 or emergency vaccine. Whether these strains with the 3 PD50 will give protection?
No, the vaccines could confer more than 6 PD50. This is an efficacious tool for control, as you mentioned, FMD in emergency. So we produce high potency vaccines with more than 6 PD50. I don't know if I am answering your question.
No, you are right. You are fully right. But my question is, in different endemic country, people use 3 PD50 vaccine, not 6 PD50 vaccine. Only in Europe, in South America, and maybe in South Korea and Japan, they use this emergency vaccine because they are having emergency stocks. But if you think about other countries in Southeast Asia where they use 3 PD50 vaccine, whether your vaccine, how you will 3 PD with 3 PD50 can be used there and can give protection, or they have to use this 6 PD50 vaccine?
Now we consider that the high potency vaccines, our vaccines confirm more than 6 PD50. That this is very important and is a key factor for the broad antigenic coverage of our vaccines. So this is important for the cross-reactivity of the vaccines and also for usage and in an emergency situation. So it's okay.
Okay, thank you. So I think we have not much time to discuss all this. Then then this is from Dr. Rayo, Sunan Rayo, to Cecilia again. I wonder what the ASKR2 2020 virus is, because there was no FMD outbreak in South Korea in 2020.
Yes, yes, I am agree, and you are right. I realize that there is a mistake in the presentation. It is not an isolates from Korea in 2020. It's the isolates from South Korea in 2010. Sorry, it was a mistake in the presentation.
Thank you. So I think now I pass you, Francisco, for the next question to next speaker.
Yeah, there is a question from Aldo Becker to Julian, and that is, stable vaccine can be produced by stabilizing the antigen. Are there other options in vaccine production for stabilization of the antigen?
Hi, can you hear me okay?
Yes.
Yes, so thank you for the question. That's true, you can stabilize vaccines. once they've been inactivated, once they're an antigen. But what our research has found is that stabilization is additive. That is, if you have an artificially stabilized virus or you have a naturally stable strain, you can increase that stability through reverse genetics. An example of that is our SAT2 paper, where we have the SAT2O chimera that significantly increase the stability of the SAT2 strain. But you can also increase the stability with the way you formulate the antigen, with sugars, with divalent cations. So yes, there's several ways of stabilizing a vaccine, and they're additive to a certain point. And I think it's important that we use them all.
So from that question, Julian, I will carry forward another question to you, please. So when you say by reverse genetics, you can mutate and stabilize the strain. So is it right? We understood properly on the VLP talk from Brian Charleston. So when this stabilization has been done artificially in the virus, it is not stable. So am I right, or I misunderstood that?
It depends on which region you're targeting. So some mutations are stable, while others have been shown not to be, and there's differences between strains and between serotypes.
Okay, thank you. And another question I'm having to ask, this is for my clarification. So when you say you showed that log 10 1.5 protective titer, so can you please let us know how much is actually the protective titer you consider for different serotype, or only this log 10 1.5 protective titer for all serotype?
For all, because that's the ag results guidelines. That's all we went on.
Okay, thank you.
I know there's differences published, but we just considered the ag results. Thank you.
Thank you. So I think, yes, Francisco, yes.
Yeah, from Teresa to Cecilia. What type of challenge do you use for vaccine potency testing in pigs?
PD50 test.
Okay. I think we are on time. That means that, Satya, that we should be closing this session.
Yeah, I think we have finished, but one question we can see, this is from Aldo Decker to everyone. So if we can discuss that, or any of us can answer that, that will be good. Aldo has asked, it is a PT reference laboratory have agreed to use pools of post-vaccination sera. With n equal to 1, it is difficult to give statistical relevant confidence intervals on the R1 value. We should change to the use of 5 individual sera in R1 value determination. Can you comment on this? I think I cannot comment on this, Aldo. so maybe it is a good question, and we can discuss later on with all FMD experts. So
Sati, I think that in the chat also there is a proposal to have that sort of discussion in the upcoming laboratory reference network meetings, and that will happen soon. And there are conversation in the chat on that point.
Okay, thank you very much.
Okay, I think that then we can close this discussion part of the session, again, thanking all the participants for the nice presentation and the answers to the questions, and thanking Dr. Parida for his excellent moderation of this session.
Thank you very much, everybody, and also the organizers. Thank you.
Bye.
Bye.
Thanks, folks.
Thank you.
Okay, thank you.